Hello world, my name is Reha. In this video I'm going to show you how to make Blender run on Raspberry Pi. First of all, what is Blender? Blender is a 3D content creation software. You can create animations, render, games, sculpting, so many things. Still images like this one. You can create robots. You can do so many things using Blender on Raspberry Pi. It works really fast and smooth on Raspberry Pi. If you take a look at the latest issue of the MacPi magazine, the official Raspberry Pi magazine, and go to page 50, there's a very nice Blender tutorial to build a 3D printable rocket. I want you to follow this tutorial and create your own rocket. You are going to be creating a rocket like this one. And in the first page it says, okay, let's see, unfortunately Blender doesn't currently work on the Raspberry Pi, so for now you will need another computer. No, you don't need another computer, so just follow this tutorial. I will create the same rocket just to make some additions to that. It's not going to be a tutorial. For 3D printing, there are very nice, useful tools in Blender. I will show those to you, but first of all, I will show you how to make Blender run on Raspberry Pi like this. First of all, you need to make sudo update, and then upgrade. After that upgrade, you need to have an upgraded version, the latest one, and reboot. Then what you are going to do is just sudo apt-get install Blender. Okay, let's see what are we going to do to make run Blender. You run the tool, configuration tool for Raspberry Pi. Sudo raspi, I don't know how to pronounce this, I say raspi config. When you run Raspberry Pi configuration software, go to 7 advanced options using arrow keys and click and press enter key, and then go to A7 GL driver. This option says I am experimental, use me carefully. I recommend you to use a separate SD card for Blender and this experimental driver. Alright, enter this, and there are 3 options. Default one is the legacy original non-GL desktop driver. It still has software GL driver, but it doesn't work well. Just select this one, the fake one, using arrow keys. Go to here. We will get into the full one in later tutorials, but for now use fake one. It is good also. And enter that. Enter again, go to finish. Mine is already selected as hardware acceleration G2, so it's not going to ask me to reboot, but for you need to reboot. And after reboot, Blender is going to work. And when you run the Blender, the first initial screen is going to be a little bit slow. Don't worry, after that it works like this, like very smooth and fast. Go to file menu, the first setup to make run better. Go to user preferences under file menu, click that and find the system tab here, upper right corner, and then change window draw method to triple buffer. It comes, I guess it is automatic. And by default, just select triple buffer and turn texturizing off it is selected by default. We don't need fancy fonts. It looks pretty well like this. And I turn anisotropic filtering off. I don't know, it helps to make it faster, but it gives me the feeling that it slows a little bit down. And one of the most important things is OpenGL select. Selection also automatic, but just select OpenGL select. There are some other options you have to select, but these are the most necessary ones to make Blender run faster on Raspberry Pi. And say save user settings, clicking this button, then you are good to go. It works like this. Now let's start creating that rocket. This is called default cube, and press X and confirm deletion, delete, and Shift A, add mesh, cylinder mesh, edit, and I want that 30 vertices because I'm going to divide 3 for the structures, this support structures. Alright, go to edit mode and then Control Tab, switch to face select mode, and with right click select the upper face and press E, extrude, press E, one more extrude, and then after to extrude just press S and scale the upper face like this, so it becomes like rocket. I press 5 in numeric pad and switch to orthogonal mode and press 1 to see the rocket from side, and I want this part a little bit more pointy and grab. When you grab this, you can move the tip like this and press Z. I locked the movement to Z direction, and then I want something like this. Okay, I will make something a little different than the tutorial in the magazine. Just select the bottom face and extrude. I extruded it. Without extruding, I just click the right mouse button and then leaves it as it is, but there's still one extra face here, so I press S and make it smaller like this, and one more extrusion to make it hollow like this. I'm making this rocket hollow inside because I don't want to waste so much plastic, and press Z. It makes our model transparent, and then grab, press Z, and somewhere here is okay, and extrude one more time, go up here and scale down. Okay, press Z again, press Tab. Now we got a hollow rocket like object, this one. So I need the support structures over here. Press 7 is looking from top, and Control 7, numeric pad 7. I'm looking from bottom, and Control Tab, select vertex and select mode, and then select this guy and pressing Shift this guy and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this next two, pressing Shift and right click mouse, selected 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and these two guys selected, and I make scale. They're now larger. It's okay, cool. Support structures are done. I just want this and parts of structures a little bit tinier, So I selected two of them and then press S and numeric. I want them numerically scaled 0.25. Now it's quarter the original size, and then click this and shift click this, scale 0.25. And why did I make this tree support structure? Because it's more balanced when you put it on the ground. And okay, so do the same thing here, 25. Then okay, our rocket is ready. Now I want to show you the additional thing, because Blender has a very cool tool here. Press N and you are going to see a window here. Just go to edit mode from here, then you are going to see a mesh analysis tool here. This is just for 3D printing. When you click this, it's going to show you the problematic faces. Type is overhang. You can analyze your object for 3D printing for sharpness, distortion, intersection, thickness. I'm going to check on overhang. Overhang means the face is going to drip, like for example this bottom face, but this face is touching down the hot plate, you know, the plate bottom of the 3D printer. So this is not a problem, but it still says, hey, this part is going to drip. Okay, the problem is here inside this one. Okay, I will show you much clearer this. Select everything, pressing A, and I'm going to rotate this rocket, like I am going to print this rocket some position like this. This is not a good position to print this object, but just to check this mesh analysis tool. Okay, take a look at the bottom. Alright, Blender tells us that these faces are problematic. You are not going to be able to print these faces, and color code tells us the level of the risk. These blue ones are less problematic, but when it goes to red color, this is the impossible to print like this, okay, because it's going to drip like this, and it is telling us that don't do that. So Ctrl Z, this is original position, and let's select this face like this, and I'm going to make that smaller, just to be sure it's not going to drip. If you make this smaller than the nozzle of the 3D printer, it's okay, there's no problem. It still will tell you that there's a problem. What happened? Where is my mesh analysis? Where is overhang? Somehow it's gone. What happened? Alright, Z. I pressed Z, now it's showing again. Okay, and this is still red, but no problem at all because it's very tiny. Now what I'm going to do is export this rocket model as STL file. Just go to File menu, export, find the export, and find the STL. It's here. Press STL and desktop. Let's make it in desktop. So give it a name like Rocket 3D. Oops. And then export. Then turn this off. Now we have here Rocket 3D, and we have a nice software slicer. It also works very well after turning on the hardware OpenGL. And add and select your model, and it's here. It works very well. And when you take a look at the preview, because of the scale of our model, it doesn't look like our rocket, so we need to make it a little larger. Select this and press scale, make it 2 times larger, and wait for the process. Look at this, lower right corner shows you it's in progress. And okay, it's a very tiny rocket model. You can make it larger. I will show you there's a problem with that, but not a big one. And you can check the plastic layers, and then check 2D layers like this, and then make export G-code, desktop, and save. It's done. This is the G-code file you are going to be sending to your 3D printer, and then get your rocket model. Alright, this is all, but I want to show you one problem. If you make your model larger, I will cover this bug. This is, I can call this a bug. This is not a big problem. Okay, let's make it 4 times the original size, 400%, and it's larger, and wait for the progress calculation and look at the preview. Okay, when your model gets larger, it looks like this, because OpenGL, hardware OpenGL is not able to handle many faces. I mean, there is a vertex for technical name. I guess there is a bug or some limitation over there, but there is no problem at all for 3D printing, because calculations are correct. If you take a look at the 2D preview, everything is fine. Just send it to printer. This is just a presentation problem, preview problem. Preview is not really correct, this part. If you make it even larger, you are going to see it's like this transparent part starts from somewhere here, and if you make a really large one and try to preview your model, the slicer is going to freeze and your Raspberry Pi is going to freeze. Just don't use preview if you are working with large models. Alright, these are the rocket creation using Blender on Pi. I just want to show you some of my projects very quick. Okay, run Blender again. I prepared some demonstration projects. I am planning to make tutorials for those. Okay, let's say you can create a part, 3D part like this. This is going to be my first tutorial. Why do I need this part? Let me show you from the animation I prepared using Raspberry Pi, this part animation. I need to fix 2 metallic rods together for a project, maker project. Let's say you also need, and you want to explain your idea to your maker community friends, and you can create animation like this explaining your project. Okay, I'm going to use these parts to fix these 2 rods together, and I'm going to use 4 pins to fix them together. Okay, this is my project and it works like this. So it's much easier to explain your project using an animation like this. This animation created by using only Blender on Raspberry Pi. Creation and rendering, and in a very short time. Works really fast. And what else? I'll show you some more thing, like sculpting. For example, you can make sculpting using Blender on Raspberry Pi. This is a sculpt study of mine. I'm not a 3D artist. I'm just learning. This is a study. I just want to show you how nice it is working. Like, okay, let's make some addition to this. Okay, look at this. Let's make a mask. You can create prosthetics and so many things using this sculpting. You can do so many things. All right, look at this. Science fiction characters you can make. Works really smooth, fast, like ZBrush and professional level softwares and computers. It's nice. We are going to be learning how to use also this sculpting. What else I have here? Open game. Yes, you can create 3D games. We are gonna allow this. This is very nice. Okay, make it full screen. I created this game using Blender. Like I don't remember, like it was like 10 minutes or something. Very simple demonstration game. Let's play a little bit. This is a box pushing game. Push the box out of the what do you call this platform, like this. There's a very nice physics engine in it, very fast. All the boxes are moving independently according to physics laws, and also I created a cheat. I can send them down using this. It works really fast for a computer like this. We are going to be learning how to do this. I didn't write even a line of code for this game, but for more complex games we will need to write Python codes. And what else? I have a car sculpt here. This is also a study when you need to create a car. You can sculpt it like this, but there are so many vertices and data. It's heavy for a 3D game. You need to retopology it. There's a retopology method in Blender, like this. Select this one and press tab. See, there are very few vertices, faces, and takes little memory, and it's much smoother. I will show you how to make retopology of your sculptings. This is a very cool thing. And what else? There is one more cool thing. This BMW is a very famous benchmark blend. This is the one. I made that a little bit simpler. I deleted the second car. There are two cars in it, to check how fast your system is working, rendering. But take a look at this object. This is a very heavy object, and Blender and Raspberry Pi is handling this very nice. Look at this. I will say this is fast. These are the things we are going to be learning in future tutorials, if you want me to continue, because this is my first tutorial in English. We have over 1,000 tutorial in our Sebilgi YouTube channel. This is our channel, Sebilgi. All the tutorials are in Turkish. We have Raspberry Pi tutorials, Scratch tutorials, and Blender, many Blender, Unity, game, software, networking, and mathematics and electronics, so many. and all are in Turkish. If you want me to continue making English tutorial, if you liked my tutorial, if you understand my English, I don't know how it is, please subscribe this channel and leave comments, so I will understand that I have to continue making tutorials in English. And if you want me to make a tutorial for a specific topic, just let me know. If I can, I will try to make it. So that's all for now. Hopefully we are going to be together in the next English tutorial. Bye bye.